Here is the scenario that should ruin your afternoon. You open your terminal, point your AI coding agent at your error tracker, and type the most ordinary command in modern development: fix the unresolved Sentry issues. The agent queries Sentry, reads back the open errors, finds a resolution node on one of them, and follows it. 30 seconds later, your AWS keys and your GitHub token are sitting on a server you have never heard of. You were not phished. Nobody breached your network. No malware landed on your disk. The agent did exactly what you asked, using your own credentials, running a command that arrived inside a bug report written by a stranger who has never touched your infrastructure. This attack is called Agentjacking, and it hit an 85% success rate against Claude Code, Cursor, and Codex. The attack starts with a small boring piece of Sentry plumbing called a DSN, a data source name. A DSN is a write-only public credential that Sentry requires you to embed in your client-side JavaScript so browsers can report crashes. It is public by design. It sits in the page source of production websites and in mobile app binaries. The researchers at Tenet Security found 71 injectable DSNs in the top million websites alone, and at least 2,088 organizations exposed across the wider internet. Once an attacker has your DSN, the attack requires nothing but an HTTP client. They post a fake error event to Sentry's ingest endpoint, carrying markdown that looks exactly like a real resolution note from your team. When your agent pulls that event through the Sentry MCP server, it reads the attacker's command as trusted guidance and runs it with your privileges on your machine. The chain has 6 stages. First, the attacker finds your DSN. It is public and searchable. Second, they post a fake error event to Sentry's unauthenticated ingest endpoint. Third, that event carries markdown crafted to look exactly like a real resolution note from your team. Fourth, you tell your agent to fix unresolved Sentry issues. Fifth, the agent reads the note as trusted guidance and runs the attacker-controlled command. Sixth, the payload exfiltrates your AWS keys, your GitHub token, your NPM credentials, and any other secret sitting in your environment variables. The 6 stages require no malware, no network intrusion, and no interaction with your machine. The attacker stays entirely outside your perimeter, while your own agent does all the work with your own credentials. Your instinct is that something in this chain should trip an alarm. Nothing does, and the reason is structural rather than accidental. Your endpoint detection tool sees a trusted process run npm, no dropped binary, and nothing flagged. Your firewall sees outbound traffic to a package registry that looks like normal development activity. Your identity and access management system sees every action performed under your own authorized credentials and finds no policy was violated. Your perimeter defenses see nothing inbound at all because the attacker never connected to you. Every defensive product you own is built to catch a policy violation, a strange binary, an unauthorized login, lateral movement. Agent jacking commits none of those. Each step is a legitimate authorized action by a trusted program under your own identity, and there is nothing technically malicious for any tool to detect. The numbers from the tenant security disclosure put the scale in perspective. The researchers tested against more than 100 organizations and achieved an 85% success rate, meaning roughly 5 times out of 6 the agent executed the attacker's command without question. The 3 agents tested were Claude Code, Cursor, and Codex, the most widely deployed agents in the industry. Sentry acknowledged the disclosure the same day, but declined to fix the root cause, calling it technically not defensible at the platform level. They shipped a filter that blocks one specific payload string, which is a speed bump and not a wall. Separately, Elastic Security Labs found that 43% of MCP server implementations they tested carried command injection flaws of their own. Agent jacking is not the exception, it is the first one with a name and a body count. This was never really about Sentry. The vulnerable component is the trust model of the tool layer itself. In the agent loop, the model reasons, calls a tool over MCP, and acts on whatever the tool returns. Agent jacking lives exactly at that last step. The loop treats tool output as ground truth, the same way it treats your own prompt. But tool output is not your prompt. It is data from the outside world, and any tool that surfaces content other people can write into becomes a channel for injecting instructions. An agent prompt, you wrote it, so it is trusted. Tool output, the world wrote it, and it should be treated as untrusted. Most agents today collapse these two into one context and treat both as authoritative. That is the bug, and it makes every version of this attack possible, regardless of which tool or platform is involved. The same attack shape applies to every issue tracker, support queue, code review comment thread, log aggregator, and ticketing system you have connected over MCP. The redesign that made MCP stateless, which I covered in a previous article, is making MCP the universal connective tissue for agents. That universality is powerful, and its dark side is that every tool you connect is another channel through which an outside party can put text your agent will later read. Anywhere a stranger can write content that your agent will eventually process, they can attempt to inject instructions. The 43% figure from Elastic Security Labs means this is not a single misconfigured server. It is a systematic gap in how the entire MCP ecosystem treats the boundary between instructions and data, and it is already present in nearly half of all server implementations tested. You do not need to tear out your agent stack. You need to stop treating tool output as if you wrote it. Right now, many teams are running agents in full auto run mode with long-lived AWS and GitHub tokens in environment variables and the agent operating with full local privileges. The shift: audit every MCP server and disconnect any that surface externally writable content you do not actively need. Require human approval before the agent runs any shell command or install sourced from tool output. Run the agent sandboxed with scoped short-lived secrets, and block the cloud metadata endpoint to limit what any rogue command can reach. The single highest leverage move on that list is the approval gate. Agent jacking depends entirely on the fully autonomous step where the agent executes a tool-sourced command with no human in the loop. Put a confirmation in front of that step, and you break the chain while keeping the agent fully useful for generation and planning. The DSN fix removes the credential the entire attack chain starts from. Today, most applications ship the DSN into the browser where anyone viewing the source can lift it, and the Sentry ingest endpoint is unauthenticated, so lifting the DSN is all an attacker needs. Route reporting through a server-side relay instead. Sentry's tunnel option lets the browser post to your own endpoint rather than to Sentry directly, so the DSN never leaves your backend, and you get a place to validate that events actually came from your own application. That single change eliminates the public DSN discovery step the attack depends on. It does not make MCP sourced content trustworthy, which is why you still need the approval gate and sandboxed credentials, but it takes your organization off the list of 2,388 that an attacker can target for free with nothing but an HTTP client. The deeper shift is a mindset one. For 2 years, the selling point of agents has been autonomy. Point them at your tools and let them run. Agent jacking is the bill coming due on that pitch. The same autonomy that lets an agent resolve a Sentry ticket without you is what lets a stranger resolve it for you. Treat everything your agent reads from a tool the way a security engineer treats a form field on a public website, as hostile until proven otherwise. In 2026, the most dangerous input to your system is no longer the one user types. It is the one your agent trusts. 3 things you can do today: audit your MCP connections and disconnect anything that surfaces externally writable content. Add a human approval gate in front of shell commands sourced from tool output, and rotate any DSN that has ever shipped in your public JavaScript. Subscribe for more on AI agents, Claude, and developer security. See you in the next one.